Okay, so I hope you can see the screen, the slides. Can you
Yeah.
confirm?
Yes.
Okay, great. So thank you very much, Giuseppe, for the introduction. Good afternoon, everyone, and welcome to this webinar on the EGI Notebook service that's continuing this EGI webinar program that Giuseppe was explaining. I will give you an introduction on the EGI Notebooks and Jupyter, covering the topics that I have here. So first, I will explain a bit what is a Jupyter Notebook, very briefly, because we can get as complicated as we want into the notebooks, because it's a very powerful system. I will just give you the main ideas behind it. Then how we are using that to deliver the EGI Notebooks service, and how this service can be used to access big data with the EGI Data Hub. And at the end, I will go to explain how to produce reproducible research with Binder and what we are doing in the EGI side to make that happen. And we will end with some Q&A session. So I get started with Jupyter and the notebook concept. Jupyter is an open source project that develops a series of tools for interactive computing. The main one is a Jupyter Notebook. This is an open source web application that allows you to create and share documents. These documents are the notebooks that contain live code, equations, visualizations, and narrative text. The idea is that with those documents, you can easily develop your research ideas and share them with your colleagues. The notebook can potentially cover lots of use cases. You can put code there, so you can program anything you may think of, basically. And here you have some listed, like data cleaning, transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. Here I show you a screenshot of a notebook running on the EGI service. So you see the notebooks is an interactive document that allows this exploration of research ideas and reproduce them later as needed. The notebook is composed of a set of cells. So you can see here the different cells, they have a number. And they are of various types. So you have markdown cells, like this one, where it says start here. It's for the narrative that explains the notebook and the code. Then you have the code cells. For example, here we have some Python code saying print hello. The notebooks are associated to a kernel, which will interpret the code, and there are lots of kernels available. Jupyter has a lot of background from Python, so there is a lot of Python usage in Jupyter, but you have more than 50 languages supported here. The more popular are Python, as I said, Julia and R, and that's where the name Jupyter comes from. But you can have lots of them, and in the EGI service we have not just Jupyter, and not just Python, Julia and R, we also have Octave, for example. And then you have other cells which are the output. Here you see it can be just some text. The result of typing hello will be a hello, but it can be also some graphical visualization of whatever you have executed before. So in this case, it's generating a plot, and you see the plot with the result. There are another types of cells, which are the row ones that are not interpreted by the notebook, so I didn't include them here. But overall, this is idea. It's a collection of cells that you can execute one after the other, and you will get the results of those cells as output. For those who are familiar with notebooks, probably you know about this Jupyter Lab thing. It's just a new web-based user interface for the project Jupyter. Before it was also web-based, but it was kind of more not so modern interface and not so dynamic. So now there is this Jupyter Lab that is very nice and customizable interface, all with JavaScript. It can be extended with lots of new libraries and third parties, not just the Jupyter environment. Others can put things here. It's high performance, and it's quite nice how you can combine tabs with notebooks, results, editors of text, and more things. So we will see this in detail later on when I show you live the notebook service. This Jupyter is basically a web-based server. You have this notebook server that run the system, where you have the different notebooks that are connected to the kernels that are the ones interpreting the cells of the notebooks. So you have different kernels. They are connected to the server with server-in-queue. And you connect to that via HTTP and WebSockets. So that's a very simplified view of the Jupyter architecture. Basically, to run this, you need to put that notebook server to start to run. You can do it on your desktop, laptop, or in a virtual machine that you have on the cloud. It's basically a local server that you start and you connect via the browser. You can install it with Conda, with pip, or even run a Docker container that is prepackaging all the stuff. It's quite easy to customize. But of course, if you're running into a public cloud, you need to be careful, because it means you're exposing this to the whole world, so you need to take extra care of security. The other possibility is not to use this local installation, but use another tool that is called the Jupyter Hub. Jupyter Hub is a multi-user version of Jupyter that has authentication and lots of customizable ways of running the notebooks. The EGI Notebooks, in fact, is a customized version of the Jupyter Hub. And Jupyter Hub will take care of ensuring the users are who they claim to be, so with authentication, and then to create a separate notebook server that can be accessed via the network and the browser. So we have here like a very also simplified architecture view of the Jupyter Hub. So you have the hub, which has three main components: the authenticator that will check the identity of the user. This is very pluggable, so you can have from simple user password to more advanced OpenID Connect or similar technologies. Then you have Spawner, that is the component that will create the notebook server for each of the user. Again, it's very customizable, and you have things that can start the notebooks in a batch queue or in a Kubernetes cluster, or just starting a new process in the machine. And that will give you a separate server for each user that this configurable HTTP proxy will redirect to when you connect. So normally you start here, you log in, the notebook is created, and the proxy is configured. So when you go inside the next time, you will just go to the notebook, and that's all you care about. So that was a very brief introduction, very high-level overview of what Jupyter is, how you can use it, so locally or with Jupyter Hub. And now we will go to the EGI Notebooks, which is mostly a managed Jupyter Hub service on the EGI Cloud. This is a service as it's available. Just go there, click into Start Your Notebooks, log in, and start using it. And it offers Jupyter Notebooks as a service. The main features, besides having the Jupyter interface, it's you can log in with the EGI AI check-in service. That means you are able to log in with your institutional ID from your university or research institution. You have persistent storage for your notebooks, so you go there, do your work, and when you come back a month later, you will still have the same files there, and you will not lose your research. And it's running on the EGI Cloud and can use a lot of computing and storage resources for powering the notebooks. We offer right now three options. One is a catch-all instance that is kind of a demo pilot instance where everyone can log in. You just go to this link, the notebooks.egi.eu, and log in with your credentials and get to the environment. Of course, since it's for everyone and free, it has some limited resources. So it's just one CPU, 1 GB of RAM, 10 GB of persistent storage, but it's free. And in order to avoid just having all the resources occupied, it will kill notebooks after 1 hour of inactivity. In any case, the files that you store there are permanent, and if you come back after 1 day or whatever, you will have the same files and you can run or continue running whatever you were running before. Just one note on the files are permanent, install libraries no, because we use Docker and we start from the same Docker image every time you start running. So if you want to have libraries to be permanent, just need to contact us and we will make it for you. Then we have the community deployments, that it's basically the same, but with all the customization that you need to make it work for your community. This can be requested by via the EGI marketplace, and we can tune it as you may need. So we can put there things like GPUs or very fat nodes. We can configure access to big data or machine learning environments like Spark or maybe TensorFlow, or anything you can think of in the terms of software that can go with the notebooks. And we can have things like not just this 10 GB of storage, but also other kinds of storage that gets auto-mounted when you start, things like going to the data hub. I will show you very briefly the data hub afterwards, or having access to any storage system that you have in your community and can be exposed to the notebooks. So if you are interested in this kind of deployment, if you can order it via the marketplace, and we will start talking about what we can do and how we can deliver the service for you. And we have a third deployment that is used for training. It's one thing that we bring up and down depending on the needs. It's also limited resources, although this is not so set in stone. Depending on the training needs, we can increase or decrease the capacity for each of the users. And if you're interested in giving any kind of training that will use the notebooks as a platform for delivering the training, we're very happy to support that kind of activity. Just contact us, let us know how many people you want to train and what are the needs per user, and we can see how to accommodate that into our system. So I will just switch to the browser. I hope you can still see my screen with the browser. Can you just confirm, Giuseppe?
No, we are still seeing your slide deck.
Okay,
no
let
problem.
me. Can I share the whole?
Yeah, I think you have a different option when you share it. Okay, yeah. Now we can see.
Yeah, it seems like I need to switch application, but it's okay. I will only do this once. So this is the training instance. This is the front page of the notebooks. You just click here on Start Your Notebooks, and it will take me to the EGI check-in service. So it's coming. Yeah. So I have already introduced my credentials before, so it's not asking me to reintroduce them. But in the case you were logging in for the first time, or if you haven't been logged in for a long time, you will need to put your credentials, your institutional ID, so of your university or research institution. Here it's just asking me if I'm okay to deliver the information about myself to the service. I'm okay. And now I will get the system start a notebook server for me. So it's creating the Docker container where I will run my things. So it's getting there. And here we are. So this is the the Jupyter Lab interface I was telling you before. So you have here on the left, you have a file browser. I have some files here with some examples that I have been running these days. I can create new ones. So I can create a new Python notebook. So this is Python, so I can just put a simple hello webinar. So this is a cell with code. I click on play and executed the cell, and it was just the output there. I can also have a documentation cell, for example. This. If I click play, this will basically render the cell as Markdown. So I can create those Python. I also have things like terminals. So I running now a shell into the same environment that the notebook is running. So here you see I have the same files that I have here in the file browser, and I can run anything or almost any Unix command here. For example, I can see what's running here with the top. Simple. So I will just go and execute some notebooks that I have. This is one using this Bucket JS visualization library, just to give you an idea of what things you can do quite easily. So you can create this kind of interactive applications where you have widgets to control visualization. So the Jupyter environment is very rich and very powerful. This is just a very high-level view of some things that you can do. There is also, for example, things like installing. Sorry, I'm trying to. Well, I have it here. So you may need some libraries that are not available in the system. For example, this one is just trying to use this BioPython. If I try to execute this thing, it will complain saying, hey, you don't have this module named Bio because I haven't installed it and it's not available by default on the notebooks interface of EGIs, but you can install it, for example, with this pip command. So it's just installed. So if I retry, you see now it's printing the right thing and I can continue executing things as needed. So again, this is a very simple example of what you can do here. So you can install things and you can work with them. The only thing, just to make sure that this will be available the next time you start, just make sure that put this kind of cell into your notebooks. And if it's a big library or something that is complex to install, just tell us, and we can put it by default into the environment. So this is a service. You have here your files. You can create files, and they will be kept there in principle forever. You see, I have files here since 1 month ago. Just to give you some more featured list of this Jupyter Lab. For example, I have a CSV file here, so you can do things like visualizing this CSV here in the browser. So this Jupyter Lab is quite nice, and you can rearrange things and so on. Okay, so it's quite complete interface for this environment. So I go back to the slides, and now I guess I need to basically go here. And I hope you see again the slides.
Yep.
Okay, so I continue with some more things that we do with the EGI notebooks. So you can access and download remote data as needed. Basically, you can program it in Python or whatever language, or even do a curl into the terminal to download whatever you need. That it can be really fine for smaller data, but if you want to access something big, it's not practical. So we have a solution based on the EGI Data Hub that allows you to access data, especially big data, in a distributed infrastructure. The Data Hub is a service that is able to combine data from different providers and move that data to the computing resources as needed. And we have integrated this transparently with the notebooks. So when you are into the EGI Notebooks service, you are also linked to the EGI Data Hub. So you have a valid token to access the Data Hub, and you can, or it can automatically do the movement of the data as you need it. We have a webinar on the Data Hub on the 4th of June, so I invite you to check this one to learn more about the service. And here I have like a schema of how things work. So basically, when you log into the notebooks using check-in, the notebooks will contact the Data Hub OneZone, which is the managing component of the EGI Data Hub that basically deals with users and knows where the data is and how to move it around. So it will contact this OneZone and generate one token that will be put into your environment so you can use it at any time. You cannot just, so you can use it because it will be in your environment, but it will also configure some libraries so you can access the data directly. It will access the data available in one provider, which is the hosting component of the Data Hub. It's where the data is stored, and we have one provider near the notebooks, so in the same computer data center as the notebooks is running. So we have very fast data transfer there, and it can be used as a cache for the external data. When you access any external data that is available into any other EGI Cloud, and this one provider A or one provider B, and it's never been used here before, the OneZone will detect that and will trigger a transfer of the data automatically and transparently as you access the file. So you just try to access and it will just happen and move the data as needed. I have a video later on with showing a bit all this flow with Finder, so you can learn a bit more later on. Sorry. We are able to integrate with other data services. It's not just the Data Hub, and we have actually done that for other services, namely the U.B2Drop, which is a Dropbox-like storage service that, well, is like Dropbox. You put files there, you can access them, you can share them, and it offers a WebDAV interface that can be mounted with views into the notebooks. Again, the system is very similar to the Data Hub. When you log into the notebooks, we will get a token from B2Drop and make things happen so you can see the files directly. Another similar one is the D4Science workspace. D4Science is a VRE system where you can have a shared file facility, and it has its own storage hub API. So we have used the different components of the storage hub API to mount with views the file system into the notebooks. We use in this case a sidecar container, which is just a technical detail. Just to tell you that we are quite capable of customizing things and mounting the different file systems with different technologies quite easily. Potentially, we can put there anything that can be exposed as volumes in Kubernetes, like NFS, Ceph, Cinder, that's block volumes in OpenStack, or anything, almost anything you can think of. This Kubernetes also allows me to get a bit into the technical architecture of how this EGI Notebooks services is set up. We are running on different EGI Cloud providers with Kubernetes, which is a cloud or container orchestration framework. This Kubernetes will run the different containers with the components of the system. The main one is a Jupyter Hub that we have customized to talk with EGI checking for authentication. And we have added a bit of, again, more customization to do some monitoring, to check that things are live, and to add this persistent storage based on NFS volumes in NFS, in Kubernetes. We expose all of that with Kubernetes Ingress, which is just a reverse HTTP proxy, and add as SSL certificate to have security everywhere. And users just connect here via the notebooks.egi.eu hostname, and that will redirect to the Jupyter Hub and to the different servers. This is just some logos of technologies that we use. So we use Prometheus for monitoring. We use the Jupyter Hub for Kubernetes, which is a quite nicely packaged Jupyter Hub components that you can just customize and it will run. And we use Helm as a package manager for installing everything. As authentication for dealing with checking, we use the authenticator of Jupyter Hub, and we have some extra monitoring from EGI to ensure things are running and have some alerts if things fail. So I move to the last part of the webinar, which is about Binder and reproducible notebooks. So the idea here is to provide an environment where you can do reproducible science. And here in this slide, I try to show the different degrees of reproducibility that you can have when you have a publication. So you have the basic or non-reproducible kind of publications where you have just a text, it's a PDF. You need to read it and understand it, and maybe you can extract from there some knowledge that will allow you to reproduce the thing, but normally it's not enough to really replicate or reproduce the research. So you can get better in the reproducibility if you add features to this publication. The first one is adding the code. So if you add the code that was used to produce the results of your publication, then maybe you are able to compile or execute that code in a way that matches what you did or what someone did before and reproduce the research. Probably you will also need the data, because the code only will get you to some point, but without the data, you will not be really able to reproduce the research. And even with the data, you will need the right execution environment to make that happen, because it's not the same running the code with some set of libraries than with another, or with compile it with compiler A or compiler B, or in a different architecture and so on. So ideally, you should also have not just the code and the data, but also some kind of executable form of the publication that will allow you to do the full replication. And that's where Binder and what we are trying to do now with the EGI and the notebooks come. So the idea is that we want to provide you with an environment where you can do the reproducible science, open science. So first, you have the computational tools to solve the problem. Basically, you have lots of languages and libraries where you develop your idea and do the research and produce some outputs. So you have things like Python, R, Julia, and lots of other libraries. So that's the initial thing that you need. You need an interface where you can deal with or interact with these computational tools. Jupyter plays that role. Putting the computational tools in the interface, you have the notebooks as a way to communicate your work. So you have the code and the narrative that explains the code, and the visualization of the output. And with all of that, you can communicate your work. We put the EGI notebooks as a way to execute and to scale up the resources needed to make the research happen. Once you have done that, you can share your work. We have things like GitHub for publishing the code, and Sonora to get this kind of repositories of research that are open to anyone. And then we have ways of replicating the research. And for that, we will use Docker with Binder. And the idea is overall, we can assign a DOI so anyone can easily find it and cite it and reuse it in later publications. So as said, we will use Binder. Here is a cartoon that explains a bit the whole thing, but with a nice figure. So we have the researcher does a paper with the experiments. She develops the experiment as a Jupyter notebook, mixing the text and the code and visualization. Once she's happy with the result of the notebooks, she publishes it into a repository, in this case, GitHub, with not just the notebook itself, but also includes the configuration and the environment that is needed to recreate that notebook. And Binder will take all of that and create a Docker image that anyone can reuse and reproduce. So this is a bit of more detail at what Binder does. So Binder takes the code from a repository. GitHub is one, but Sonora is another one. Creates a Docker container from that repository. It generates a user session into Jupyter Hub that can serve those containers, and all of that runs on top of Kubernetes. And there is a public Binder instance that is hosted in several cloud providers and managed by some university in the US. And in the case of EGI, we are working also to provide such a Binder instance where everyone could create, share the sessions of these interactive notebooks. So the idea that we want to enable is that first you go to the EGI Notebooks, develop some research idea and create a notebook that can be the publication. You access some data in the data hub that is identified with a PID, a persistent identifier. So all of that is shared into a repository, GitHub, that is then fed into Sonora to get a DOI. And then anyone can discover that DOI and use that one, put it into Binder, and get a new environment exactly the same that you had in the beginning, and accessing the same data that you were using at the beginning, since you have the same PID, and reproduce the research. So I will show you an example of this. This is a GitHub repository of a notebook with its environment described, and it's published on GitHub. So here I have the repository. I have some, well, basically it's just boilerplate, just authors, copyright license, some README, and this is the main file, I will say. This is the environment that is will be recreated with Binder. So it's basically saying what I need to install. In this case, I'm not putting exactly the exact versions, but as good practice, it should be put there, so you can ensure that you're getting exactly the same environment as you were doing initially. So I have a set of libraries, and I have some of them also dealing with the data hub. So this GitHub repository was published in Sonora, and here I will show you a video that will show how you can start from Sonora and get a notebook that will reproduce whatever idea the researcher was trying to have initially. So I click play. You start with Sonora, you get a DOI, and that DOI can be used in the Binder instance. This is the EGI Binder instance. We will put there the DOI from Sonora and click launch. This will start creating a new environment just for you, exactly the same that was specified in the environment. So this can take a bit. I basically recorded this in video to cut the waiting times, so it's faster and we don't take too long into the webinar. Now it's building the thing. It has finalized, and then it's launching the Jupyter environment for you. So it should be done now. It's saying server is running. So you have, in this case, is the classic notebooks environment. Here is the notebook that was created originally, and you can have it in the same way. And this is just clicking run to make it execute. So it executes as we are going through it. In this notebook, I'm using some data from the data hub that it's identified with that PID. So if I resolve that PID, it will take me to the data hub interface where I can see the data. This is taking some sea datanet data of temperature of the Arctic, Baltic Sea, and Black Sea, and it will just display it on a map. So what the notebooks is doing is taking those files from the data hub. So you see the different files, they're red. It has downloaded the data. It's like 1 GB of data. It's just exploring whatever physical information about the temperature of the sea is there. It will do the same with the other seas, with the Baltic and the Black Sea, and then it will put everything together and plot it into a map. So it's basically just doing that. It's putting the data together, and now it's creating the map where you will see just the data displayed. So it's getting there. There it is. So you see the map with the temperature of those 3 seas in a map. So this is a very simple example because, I mean, it's not real research, it's just plotting some data files. But again, potentially you could put here any kind of research idea. You can develop as much as you want. You can access any data you can think of, and you can easily make it shareable to others and make others being able to reproduce your research quite seamlessly. So as I said, we are working on this EGI binder service. It's now in alpha for restricted users. We are trying to understand how to make it work reliably for more users. Right now, again, we are limiting to 1 CPU, 1 GB of RAM, and 10 GB of persistent storage per user. And we are trying to make this ready for wide access in the coming months. So stay tuned for more news here. That's the latest. This is the last slide of the webinar. Summary: Jupyter Notebooks is an interactive, exploratory, and reproducible format for your research. We provide notebooks as a service with the EGI Notebooks in the cloud without the need for you to manage the services, capable of accessing data on the EGI Federation, and we can tune it to meet the needs of your community. And we are looking into Binder to provide reproducible and open science. So we hope to have this ready soon, so you can go and use it. And with this, I would like to invite you to go to the notebooks.egi.eu URL and get started with the service. So that's it. Thank you very much.